Welcome to the Transum podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Hello, and welcome to podcast number 136 for the month of March 2026. So, let's get on with it with the puzzle of the month.
A penguin starts to waddle from a sandcastle to the rocks on a beach, at the same time as a crab starts to scuttle from the same rocks, heading for the same sandcastle. They pass each other at 11 a.m, and the penguin reaches the rocks at 1 p.m, while the crab doesn't arrive at the sandcastle till 3:30 p.m. What time did the waddling and scuttling begin?
That's the Transum puzzle for this month. The challenge is set. Have a think. Make a plan. You have 1 month to figure it out. Send in your solution as soon as you can.
So, with all that waddling and scuttling, can you figure out what time it all began? Please let me know if you do at podcast@transum.org. Okay, here are some of the key resources. We keep adding more and more. Well, I keep adding more and more resources to the website. And the first one, just gone live, is called Speed Skills, which is a self-marking practice activity, as you're familiar with, which, it's designed to help students build confidence with speed as a rate, because that's quite different to other measurements that students are used to. It's usually measured in meters per second, or kilometers per hour, or miles per hour. And the exercise focuses on choosing the correct formula to use in different circumstances, whether you need to find the speed, find the distance, or find the time. So the students need to read the questions carefully and decide what information is actually needed. Some of them have some distractors, some additional information that's not needed. And then they need to type in their answers with the units, and really any sensible units will be allowed, because there are multiple different ways of writing kilometers per hour, for example. Have a look, see if it's suitable for your students, and if so, let me know how it goes. Crossing bridges is a challenge, an engaging challenge. Students need to find a path that crosses every bridge exactly once without repeating any bridge. The activity features 5 progressively difficult challenges, and it's based on the 7 bridges of Königsberg problem that inspired mathematician Leonhard Euler to develop his graph theory in 1736. So, hopefully, students will develop strategic thinking and problem-solving skills as they work their way through the challenges, and learn to analyse networks and plan their routes carefully. So that's called crossing bridges. Now, all the things I'm talking about here in this podcast, you can find the links in the newsletter, transum.org/newsletter. Murmuration. Have you ever heard that word before? It's a new challenge requiring students to estimate large numbers of items while they're moving. So it's a real challenge. There's another activity on the website involving estimating numbers of sheep, but conveniently all the sheep stand still. But this one, the birds in the murmuration, I only learnt that word about a month ago, are flying in the sky. They're moving around, so you really need more estimation skills, and you can't rely on counting skills because it's virtually impossible to count the birds as they fly in their patterns. Anyway, so we have some increasingly complex scenarios, I guess. 50 birds, around about 50 birds in the first challenge, and going up to 1,000 birds towards the end. So students obviously don't have to get the exact number of birds, but if they're within 10% of the actual number, they can get a trophy. So this is a beautiful physics-based animation, so that keeps students engaged. Hopefully it's something different. It's quite different to something you'll see in a textbook, and making reasonable estimates, of course, is a very useful skill for everyday life. But health warning here, it can be like really mesmerizing watching the murmuration. And if you've not heard that word before, you heard it here first. So look it up if you're not sure. But it's about the patterns that I think it's starlings make in the sky just at dusk when they're all gathering ready for bedtime, I guess. Okay, another new activity. Remember, the links are in the newsletter. This one's called Transformations of Trig Graphs. Now, this is not meant to be the only activity that students do when they're learning about the way graphs transform according to the parameters in the equations. So I would assume that I've done this in a static form because this is very dynamic. The waves, the sine waves and cosine waves, etc., move across the screen as they would do with all that equipment you see in labs that you don't really know what it does, but you see these sine waves moving across the screen. So it's a little bit of fun, something different, and what they have to do is there's a red curve which is the target, and then there is a blue curve, and they both scroll across the screen, and what you have to do is edit the equation of the blue curve so that it matches the red curve exactly. And there's built-in checking in the software, and it will give immediate feedback as to which of the parameters you've got right and which of the parameters you need to still adjust. So maybe you could use it as a starter or a homework task, or a bit of focused practice when pupils need to sharpen their graph interpretation skills. Have a look at that. Transformations of trig graphs. Okay, the largest product challenge is not new, but it has been updated to prevent clever and mischievous students from cheating. Tut tut tut. But they keep me on my toes all the time because they find new ways of having a look at the source code of the web pages and trying to find ways of getting shortcuts. But so I've used the software to rewrite largest product, and now it's ready for students to use. You see, the thing is, you're allowed to put the numbers on the line, and then you put multiplication signs in front of the numbers, in between the numbers, and you try to find the way that will give the largest product. And some students realize that if you put two multiplication signs together without a digit between them, the software considered that as being a shortcut for to the power of. So they were getting some ginormous totals. And when I noticed that and then finally figured out how they were doing it, that's what motivated me to rewrite the software. So, largest product, link in the newsletter. It's quite a good challenge. Have a go. Now, one of my students showed me something new, and it's always good when a student shows you something that you hadn't seen before. It gives them a great sense of achievement and ownership and motivation to find these things. And it's all to do with remembering the common trig ratios, like the sine of 30 degrees or the tan of 45 degrees, etc. And it was I've seen mnemonic diagrams for this before, but this was a new one that I'd seen, which was quite nifty. And I've put it in the newsletter, and I've put an explanation for how to use it on the common trig ratios exercise. Again, links in the newsletter. So, should we be using mnemonics to remember maths? Well, I think sometimes yes and sometimes no. So I think this one, and any sort of well-chosen mnemonic, it's not about replacing understanding. It's about reducing cognitive load so that students can focus on the real mathematics and the problem solving, etc. So for this case, they could draw right angle triangles, and there's two little triangles that I use. There's a video about this, by the way, in order to quickly work out I say quickly, it's a bit slow actually, because you've got to draw these triangles and use Pythagoras to work out what the sides are, and then from that figure out what the trig ratios are. So it's so this mnemonic gives them sort of instant access to the standard values and lets them really concentrate on the problem solving and making connections. So I guess it's like, in the same way we don't expect students to reinvent multiplication facts before tackling algebra, we expect them to sort of memorize them. And in the same way, I guess this achieves the same purpose. So having said that, I've also just literally yesterday made a video to go with the speed skills exercise that I mentioned earlier in the podcast. And in that video, I have absolutely avoided do you know the little triangles? The little triangles split up with S, T and D inside them. And students can quickly work out the way the formula goes by covering up the thing they want to find and seeing what's left. So I don't think that's a healthy mnemonic, because rearranging speed equals distance over time can be done very quickly, and it fits in with the rest of the algebraic skills that we require students to have. So I always avoid those. So mnemonics, sometimes yes, sometimes no. Okay, so the month ahead, here are some important dates. Well, dates where there are related activities on the Transom website. So the 14th of March is the big day of the year for mathematicians. It's Pi Day. And there is a link in the newsletter, for all of these, I won't keep saying it, for the activities that go with Pi Day, the 14th of March, when the digits, if you write the date in a certain way, are the first three digits of pi. There we go. On the 17th is St. Patrick's Day. Now, I don't have maths activities for All Saints' Days, but this one is a limerick and it just fitted nicely with the Irish theme. So 17th of March, St. Patrick's Day, and the 21st of March is Poetry Day. And I'm quite proud of some of the maths poems that I've come up with over the years, and I freely share them with you. So have a look for the Poetry Day resources and see what you think of the poems. So finally, the answer to last month's puzzle, which was...
Percy and Nellie Codd are brother and sister from a large family. Percy was 19 pence short of the amount needed to buy a badge. Nellie, meanwhile, was just 1 penny short of affording the same type of badge. They decided to pool their money to buy one badge to share. But even together, they still didn't have enough. Here's what we know about the Codd siblings. Percy has 3 times as many sisters as brothers. Nellie has twice as many sisters as brothers. How much would it cost Mr. and Mrs. Codd, Nellie and Percy's parents, to buy badges for all of their children?
So the answer is that one badge costs 19 pence, and the total number of children is 13. You can figure out from the second part of the puzzle. It's like 2 puzzles in one, this, isn't it? So the total cost for Mr. and Mrs. Codd will be 13 times 19, which means the total bill is £2.47. Now, only one person managed to solve this puzzle. Well, only one person managed to solve it and send me an email with their method. So I am super grateful to Rick, and you can see his solution at the bottom of the web version of this podcast, the newsletter. Thanks very much, Rich. I was feeling quite lonely until I received your email, and very excited that someone had done the puzzle. So great to hear from you. So everybody, try this month's puzzle, and if you manage to solve it, please send me an email to podcast@transom.org. So that's all for now. Oh, apart from to say that it's the first day of the month. We all have a long march ahead of us. I hope you don't get blisters.
Thank you for downloading and listening to the Transom podcast. You can find the website at www.transom.org, where you're welcome to use all of the activities absolutely free. Or jump in with both feet and become a Transom subscriber.